Well, hello everybody, and welcome to this morning's webinar, which is entitled Data Quality Assurance. My name is Andy Osborne. I'm Director for Global Business Development for CA Experts, and I'll be joined today by Christine Reck, who is Product Manager and Senior Consultant. In terms of the agenda today, I'm going to go through a brief introduction, just set the scene around the Quality Assurance Module, which is really forming the main basis of the webinar this morning. We're then going to go through a technical overview, and I'm going to hand over to Christine to do that. She's going to show you the data quality checks for both the P&ID instrumentation electrical and also for Smart Plant 3D. She'll also highlight the quality check filters, user-defined calculations, etc. Following that, she's going to hand back to me. I'm going to go through the summary, quick poll surveys, and then we're going to go on to the audience questions. So please enter your questions as we go through the webinar this morning. We will answer as many of those as we can at the end of the session. Totally, it should last about 30-45 minutes. We are recording the session, and this will be made available as a viewing capability in the next 2 days, so you don't need to worry about that. Okay, so without too much more to say, I will move on to set the scene. So for those of you familiar with CA Experts and what we do, we've had reporting tools for some time. And on the left-hand side of this diagram, you can see there are various different applications that we connect to. And we connect to these through these adapters. Some of them are report adapters, some of them are edit adapters, which allow us to write back any changes to the specific applications. And as you can see, Smart Plant P&ID, Smart Plant 3D are two where we have these edit adapters. So all of these other applications that you can see, these are accessible through these adapters. We can then generate reports through the application reporter, universal reporter. Well, what we've done, we've actually added a module on here called the Quality Assurance Module, which gives us the ability to validate the quality of the data that we have in a number of different areas. And of course, because it's a part of the Universal Reporter, it means that we have accessibility to all of these applications that the Universal Reporter does as well. And that's going to form the basis of what Christine is going to show you very shortly. Just to give you an idea in terms of the kind of workflows or the scenarios it could be used, all of these applications we've been talking about could come under the banner of engineering systems. Now, these could be standard engineering systems like the P&ID, the 3D, or it could even be any in-house written database type application, whether it be for procurement, for materials, project controls, whatever, it doesn't matter. So really what we're doing is we're using these adapters we talked about to access the data from these systems. And then we're using the Quality Assurance Module to generate the reports, the difference checks, so on and so forth. And that's what we're going to do in terms of the basis for today. Now, having said that, that's what a company can do, but equally this could form the workflow in terms of an EPC and an owner-operator, where the owner-operator is really looking at the data quality assurance. They want the EPC to concentrate on the design phase of the project, and they could take responsibility for that simply by looking at the data through the adapters that we can provide. And of course, as your project increases in size and the number of contractors increase in size, you can even move that to sort of a multi-contractor view, where the contractors could even be responsible for their own data quality, but then the roll-up view is being handled by either the PMC or the owner-operator. So hopefully that's fairly clear in terms of the usage and the application of this type of tool. So from this point, what I'm going to do is hand over to Christine, and Christine will give you a run-through of what it does and how it does it. So I'm just going to hand over to Christine now. So hopefully, Christine, you've got access.
Okay. So hello everybody, also from my side. The first thing that I'm going to show is the interface itself of the quality assurance module. As you can see in this interface, we are working on data that comes from a report adapter. So in this case, you see here in the brackets, it's P&ID data. On the left hand, you see ppm, which is the name of the plant I'm using. And I have opened this file with the quality assurance module. In here, we have the possibility to define filters that will check the data. And we have a property grid, which is displaying the data coming from the different tables that have been extracted from P&ID. So if you're familiar with Universal Reporter, you already know this configuration. We have equipment nozzle data, pipe run data, instrument data, even OPC, item nodes, etc. And in here, you can choose the table. And then we have a list of common functions, which I'm going to briefly show. So for instance, if I just want very quickly to find everything that has 001 in the name, I can search for it. If I want to see where do I have maybe 80 millimeters in this data set, I can search for it. And it's a very easy find function that works here in this grid. And then we have additional functions like sorting by clicking on column names. We can filter by using the little filter icon that is available at the column level. And then we get, for instance, just data coming from one drawing, from another drawing, and we can, of course, switch back to all. We have some special features in here, for instance, like grouping by an attribute. And in this case, we can use the full expand mode to see the whole data, which is grouped, in this case, by the drawing name. We can take the attribute back to the grid. And we can also move attributes around and put them in a new position. And all the configuration is stored in a view. So if we want to save this new configuration, we can just click here on the Save View, and it will be stored. And another, I think, very important feature in here is that we can use a column manager to add or remove attributes from the grid. So for instance, if I want to see the vessel volume rating, you see it will end up in the last column. I can switch it on, I can switch it off. And also a very nice function is the preview on the attribute level. So if I click on an attribute, doesn't matter if it's on or off, I do see the values that are behind these attributes. So here we always display the list of the first 10 values for the attribute. Okay, so much to this basic functions in the grid. Now I'm going to the real interesting part. The interesting part is, of course, how are the filters defined and how do the quality checks work. You see here on the left-hand side, we have a list of folders, and the folders contain at the lowest level filters. This structure can be very flexible, so every user or administrator can build their own lists and their own folders. And we will start with the first one. Let's say we are looking at equipment data from P&ID, and we want to check if all the equipment have a dash in the name. So what can we do? We can define a filter. This filter has a visual interface possibility, and in here we would just say that we are checking if the item tag contains a dash, and of course only if it's not null, because if it's null, it doesn't make sense to check for a dash or not. On the middle side that you see here, we have the style options. So how do we want the results displayed? We can choose a color, we can choose a font, and we can also choose the text color, how the text will be displayed. And we have the possibility to choose either all columns to be applied in this filter, or we can just choose the item tag as was done here. We have a preview function which will apply the filter and the style so that we can see what's the result. And if we are satisfied with the result, we can just say we want to apply this filter. And then we can activate the style and eventually also the filter. So in here, you see you have two possibilities. You can just apply the filter, or you can just apply the style, or you can apply both, and then it will be, of course, the style and the filter. And here in this lowest level line, you always see how many records were identified by this filter. So this is the principle. And now I'm going to show you also some other checks. For instance, in the same equipment area for PIDs, I have defined a filter which is looking if a nozzle which has an item tag doesn't have a nominal diameter. The filter is really looking at nozzle item tag not being null, but nozzle diameter is null. And again, I have applied a color. I did not make any font change, and also no other text change here. So if we just preview this, you see we get the nozzle item tag and also the nozzle diameter with this color applied. So you can choose as many columns as you want to check the results. And if you want to go out here, I can also show you that it's possible to apply at one time all the styles for equipment and nozzle checks. And you can also apply, if you want, all the filters. In that case, you will only get data which does have a rule violation. So this means you will see all the applied checks at one time. Let's take the filters away and just keep the style applied. One very important feature is that you can always export the data to Excel. So I'm going to export it to PIT equipment and open the Excel file. And you see we have exactly the same interface like in the grid. You see on the left side the check for the item tag. You see the check for nozzle item tag and nominal diameter, the missing pipe run information. And quite a nice feature is that in this case I have created an artificial column. I will show in a minute how this looks like. And with this artificial column, you can activate the auto filter. And if you apply this X as a filter, you can also in Excel just see the rows which have a rule violation. And to give you now a little explanation how this works, you see this column here at this side is a special column. It's an edit column to the grid, so it does not come from the extraction. It did not come with the extracted MDB. And if I click on Edit Worker Column, I have here a couple of logical queries which are performing the same checks like the original queries, but they put the data in the last column, and so you can really have an additional filter possibility, which you can even use within the grid. If you want only to see the checked rows that have the rule problem, you can activate it also here, and you have this very good possibility to add additional columns to the grid. So we talked about equipment checks in PID data, and I'm going to move forward now to instruments, also coming from PID. You see we have again a table which displays instrument item tags, which display the connection to the pipe run, connection to the equipment, if there is any, drawing name, instrument loop tag, and so on. And I have configured several checks in here. The first one is a very simple one. No loop association, just displays the instrument loop item tag is null, and it gets a color applied. We can again use the preview. We can apply the style. The second one is a little bit more complicated in the sense that here I'm checking if the instrument modifier is missing. Like in this first row, you see there is an F, and then there's a dash and a number, but there is no I or A or this follow-up letters in the instrument tag. So this rule is checking the substring of the item tag from the second position and with the length 1, and it checks if it's a dash. So if the dash is directly on the second position, this rule will apply. And this means that with this way, we can activate both checks, no modifier, no loop association, and there's a third one that is also looking at substring level. And this one is checking if an instrument has an E as a modifier or a V, which means flow elements, control valves, and the check is looking if the connected pipe run is null, yeah, because this is not correct to have a flow element or a control valve that is not really lying in a pipe run. So if we also apply this one, you will see we have some rows where the blue color shows that there is no connected pipe run to these elements, while the other flow valves do have a connected pipe run, or the other flow elements. And here I have a very nice example for calculations that are possible in the grid with virtual columns. So the first one is again applying a logical query. So if the first rule is applied, we get a no modifier. The second one will show no loop, and the third one will show no line number. So this means this column, which you see here, is a result of the IIF statement that we are using. So we can very easily find out which is having no modifier, which is having no line number. And in the end, if we switch this one back to all, we have the same possibility like I already showed in the equipment area. We can see was there a rule violation or not, because this X is activating all the checks. So you see the feature with the virtual columns is, I think, a very good one to make an overall check in addition to the existing rules that you can define and use at this stage. Now, let's see how this looks like in the pipe run and piping component area. So I switch over to inline components and pipe runs coming from P&ID. Here you can see pipe run item tags, drawing names, piping material class. The piping material class, for instance, has some wrong values in my data set. These are too long, for instance, because it's just allowed to have 7 spaces but not longer. Then I have design max pressure temperature, and if we look through this data, you can see that there are some values in here that don't have the blank between the value and the unit of measure. And I will just apply the rule so that you can see the result. I have 3 rules configured here. One of them is checking if design max temperature contains blank, and if it does, it will show it in this pink color. The other one is checking if design max pressure is null, and it will show it in this rather blue style. And the last one, or better said, the first one in here, is checking if the piping material class has not more than 7 characters, and if it does, it displays in the green color. Let's have a short look at the rules. This one is checking if the piping material class is not null, and the length of the piping material class is larger than 7. And if this applies, it will bring the result that you have seen in green. The next one is looking if design max temperature contains a blank, and is looking if it's not null. And if both of these are applied, you get this pink color. And as you see, these rules, they have a visual interface, but they also have a text interface. And in the text interface, you really see the real text for the filter, And this is something you could very easily copy to a text file and copy it back in. So there's no need to only keep the rules in here. You can also use, let's say, a portable style to keep them if you really want, as examples or explanations and these kind of things. What I want to do now is show you how easy it is to copy a rule. So let's take design max pressure null, check, copy it, paste it. We have a new rule in here, which of course I would have to rename. So for instance, 04. And then we just rename it to temperature. We also rename this description over here. And then we can just click on the attribute, choose the other attributes that we want to check. And in here, of course, not forget to apply the color to the different attributes. And if necessary, also select a different color like this yellow. And we can use the preview. So now we have all the design max temperatures that are null. And if we like the result, we can say apply and OK. And you see we have this new rule. We can apply them all. And it's very easy to define such a rule. And if we have a little look at this length check for piping material class, we see this interface in here. And in this interface, we have access to the fields. We have access to operators. We have access to functions. And one of these functions is the length function. But we also have, for instance, in the string area, functions like char, ensuite, contains, replace, substring, etc., or trim. And you can use all these functions to perform your checks. Okay. The last thing that I want to show in the P&ID area is how easy it is to create a new column. You would click in the grid on top and say that you want to add a virtual column. If you add a column, you have to give it a name. So I will call it v_int temp. And I have to choose a data type. I will choose string. And the idea behind this example is you create an additional column where the data that now is in design max temp shall be copied. And then you can use this new column to import it back to P&ID and to fill the insulation temperature with the values that it will find in this artificial column. So I will click on fields, and I will just tell the new column that I want to take the values from design max temp. Say OK. Let's give this OK. Now we have the artificial column in here. It has exactly the same values like the ones that you see in design max temp. I can export this to Excel. And you see, you have the original columns, you have the new column that we have created, you have all the checks available. You could even use the Excel file directly to correct some problems or whatever you find in here, and then take the result that you store in this Excel file and import it back to P&ID, for instance, using Universal Reporter together with the edit adapter. So it is very easy to configure the reports. It is very easy to find out any, let's say, things or data that is not complying to the rules. And you have an interface which you can use to create Excel reports. And one more thing which I forgot to show in the Excel report, we don't only export the data with the applied rules, we also export the filters with their descriptions and how they were applied. So this means in here you have a second sheet in Excel which also shows the filters so that you know that when you look at the data, what does this color mean and what does the other color and style mean. Okay, I'm going to leave now the P&ID area and I'm going to switch to instrumentation. So as you see, I have here a view that is coming from an SPI database. The plant name is the same like the P&ID plant, but here it displays the information that it comes from SPI. In here we have the tables coming from SPI, like instrument loop, etc. And I have defined 3 checks for SPI, which are quite more or less the same like they were in P&ID. Instruments with no loop number, instruments with no modifier. I had to use a slightly different query because I'm checking for the blanks and not for the dash at the second space because of this naming convention here. And the other one, which is checking if an instrument is FE or the second character in an instrument name is V and the line number is null. So it's pretty much the same like in P&ID. And you can also export it to Excel and you have exactly the same functionality like what you have seen in the P&ID area. I'm switching now to electrical. For electrical, I have defined checks for 2 tables. In the wiring area, you have cable data. And the rule in here is checking if a cable needs sizing. In this case, it will get a sizing flag true. And this flag is combined with a filter so that you can see this green color also for the item tag. So if we look at this filter, you see I have configured the sizing flag plus the item tag to display the same color. And also very important, if we switch to electrical equipment, just as an example, I have defined 2 rules. One of them is checking if motors have an M in their name. So I'm using the subclass and then if it contains an M. And the other one is checking area class against exposure protection. So for instance, zone 1 does not allow general purpose. Zone 2 does not allow general purpose. And we can see the result displayed. We can also apply the filter, of course, so that you can have only these results. And let's take this filter away and this filter away. And then you see in the red color that there is a motor which is in area classification zone 1, but it is displayed as general purpose, which is wrong. And it's very easy to identify these, let's say, rule violations with the quality assurance module. Last but not least, I'm looking at a 3D data set. The 3D data set comes from SmartPlant 3D. The plant is called Madison. We will have a look first at equipment data. For equipment data, I have defined 2 filters. One of them is checking if an equipment number has no dash. And if we look at it, we can see all equipments that don't have a dash in their name, they get this style. And the next one is checking if there are nozzles which are called copy of. And you see there's a lot of them in my example data set. Even copy of, so they have been multiple copies. And it is very easy to identify them using the contains statement in the rules. And if we have a short look at piping, I have defined checks that are looking if design max pressure is null or 0. So there are 2 conditions in here, null or 0. We can also add, of course, more conditions if we want. And this is displayed in blue. The fluid type, which is not defined, is displayed in this color. And then I have special checks, like, for instance, piping material class must be 6 characters long. If it's not, it gets the green color. and the units must be in inch in this plant. If they are not, they get this, let's say, red-brown color or whatever it is. And it is very, very easy to apply these rules, to perform these checks. And I hope you have been able to see that it's always the same strategy, it's always the same functionality. It doesn't matter where the data comes from. You can define the rules, and you can apply them against the data set, and you can create very easily results that you can export to Excel and hand them over to people who are going to look to correct these issues, to add data or change data, or even import the data back using these reports to applications like P&ID or SmartPlan 3D. Okay, maybe last word from my side. These reports can also be configured to run in batch. So if you define a rule set for P&ID, a rule set for 3D or for SPI, you can also generate batch reports so that in the end, when you come in the office, you will find the checks automatically lying on the table, or at least lying on your computer. Okay, so thank you from my side, and I will hand back to Andy.
Okay, thank you, Christine. Hopefully that was clear for everybody. So what I'm just going to do now is finish off in terms of summarizing. I know Christine's just really summarized the, the application requirement that there is. But clearly one of the things that we intend to be doing is to track and report changes between different stages of a project. Now we can do that through the Universal Reporter at this time anyway, but we intend to enhance the Quality Assurance module to do that too. So we can audit data with company-specific rules which result in color-coded spreadsheets, and I think that was very clear from Christine's presentation. You can actually verify data quality prior to loading into any enterprise system or prior to handover to your client. You can do item tag checks across applications, including the customer's own applications. So the one thing we didn't make very clear is, although we've got this, these different report adapters that give us access, it's relatively easy, a few days worth of work, to enable an in-house system with an equivalent custom adapter. So we can access any data that's you need to verify in this way. Data maturity checks can also be generated. Again, one of the things that Christine was showing was the addition of virtual columns and potentially putting in calculations around the data that's already held in other fields. So that could be purely something like a calculation that establishes percentage data maturity for any individual tag. Clearly, reduction of data rework through simple and effective inconsistency reporting. We can really understand where the issues are. We can see them visually. We can we can change them and put them back into the system.